Dear students, so welcome to our class on basic pressure laws. These are very fundamental and basic pressure laws. What we are going to learn in this class are Dalton's law of partial pressures, hydrostatic equation, pressure gradient, hydraulic equation, geostrophic gradient, cyclotropic winds. It's very simple. Not at all, and not at all difficult. So these are all the things that I am taking from my own book. Basic principles of agricultural meteorology, written way back in 2002 between. So earlier I started writing it some 15 years before. So these are the fundamental basics, So there is no deviation even today or even 100 years to come, because these are the basic equations. Of course, unless otherwise some great scientist in you change it, it will never change. Anyway, good. So welcome to what is Dalton's law of partial pressures. Very simple. In page number 82 I have written there. What did I write? Now, see, the law of partial pressures states that the total pressure of a mixture of two or more gases or vapor is equal to the sum of the pressures that each component would exert if it were present alone and occupy the same volume as the whole mixture. Very simple. If you take oxygen, nitrogen, carbon dioxide, whatnot, you take it. You take it in a container. What is the Dalton's law of partial pressure state is that the pressure exerted by each of these gases, okay, sum of these two or three gases which you have given is equal to the individual, okay, when each one would exert, it is equal to that one. Simple, very simple. The law of partial pressure states that the total pressure of a mixture of two or more gases, okay, or vapor is equal to the sum of the pressures that each component would exert if it were present alone, okay, and occupy the same volume as the whole mixture. 1, 2, 3, okay, 1 plus 1 plus 1. What one is putting, second is putting, third is putting, sum of it is the Dalton's law of partial pressure. Simple. So let's go to hydrostatic equation. So very simple equation, very interesting equation. It has got wonderful applications, so that I will be telling you in the days to come. Let us see the basics of it. The rate of decrease of atmospheric pressure, I told, pressure is force per unit area. Atmospheric pressure is the pressure exerted by a column of air which is extended out to outermost boundary layer of the atmosphere over a square centimeter or square inch. Okay, now see, based on that, the rate of decrease of the atmospheric pressure with the height is equal to the product of the density of the air and acceleration due to gravity. Okay, this is very simple hydrostatic equation. It expresses the equilibrium between the atmospheric pressure and the force of gravity at any point in a non-moving air parcel of the atmosphere. This equation holds good when we presume it as a non-moving air molecules, air parcels in the atmosphere. So this is a very interesting. It has got a lot of implications as far as movement of water from the roots to the stem and all those parts of the trees, bigger trees, these have got very good equation. Pressure gradient. So what is pressure gradient? It's very interesting. Pressure gradient, difference in the pressure. How it happens? It is defined as the decrease of pressure between 2 points along the line perpendicular to the isobars divided by the distance between the points. Very simple. Isobars are the lines drawn connecting the points of equal pressure. Okay, equal pressure is there. Now, what is the pressure gradient which will come? GRF, SRF. Please understand. It is defined the decrease of pressure between 2 points. Here is the point, here is the point. The decrease of pressure from this point to this point along the line of perpendicular to the isobar divided by the distance between the points. So this is what we call it as the pressure gradient. The isobars drawn closely on a weather map represent the steep pressure gradient when isobars are drawn very close. Okay, 982, 980, like that. close. It represents the steep pressure gradient. When isobars are drawn apart, it indicates the weak pressure gradient. So the pressure gradients are one of the primary causes of airflow or wind with the direction of flow from which pressure to low pressure areas. Of course, see here I would like to impress upon is that see, if you look at a tree leaves are there. The wind blows from high pressure to low pressure. It's natural. Low pressure, high pressure to low pressure. Now, movement of the branches, movement of the leaves would never be on one side. So, this side, that side, this side. So, why? Because it is a high pressure to the, for example, it's an example I am telling. So, from high pressure to low pressure to from other area to another area, high pressure to low pressure in another area. So these are all the things that make the trees to move when wind is blowing from different directions. Okay, it's not exactly pressure gradient, but pressure gradient. Another example, what we see in the crop field. That's what I was interested upon. Okay, Dalton's law of pressures, hydrostatic equation, and pressure gradient. I have taken from these my own book. The other things that I have taken are from my own books, Terminology on Agricultural Meteorology and Agronomy, written by me, and also my very old when I was joining in the service, these errors. Technology like this, from that book, I have taken these very interesting three things, hydraulic equation, right? Geostropic gradient, cyclostropic, three minutes I will tell. Very simple, very interesting. What is hydraulic equation? Hydraulic equation, simple. Even 10th class, intermediate, okay, we study it. What is it? Force is equal to mass into gravity. Pressure is equal to force by area. Pressure is force per unit area. That's what. The pressure is defined as force per unit area. That's what is hydraulic equation, basics. Now, the basis for all the hydraulic systems is expressed in Pascal's law. See, this is very interesting. Which Pascal's law? What Pascal's law states? The pressure exerted anywhere upon a closed liquid, okay, enclosed liquid is transmitted undiminished in all the direction to the interior of the container. If we exert a pressure in a container, so from that point, it spreads equally. Pascal's law states that one. Very simple. Pressure is equal to density into gravity into fluid height here in the Pascal's law. What actually pressure is force per unit area. What Pascal's law says that, once again I would like to impress upon you that, it states that the pressure exerted anywhere upon an enclosed liquid is transmitted, okay, undiminished in all the directions to the interior of the container. When we put the pressure goes equally within the container. This is the, of course, Pascal's law. So this principle allows large forces to be generated within a relatively little effort. See, I would like to tell you, you take a square inch or square centimeter, put 5 pounds power force. 5 pounds force in a square inch. If you take 10 inches, okay, 5 pounds. So 5 pounds for only about 10 inches. 50. Okay, that's what is the hydraulic equation. It has got lot of implications, not only in agricultural meteorology, general meteorology. Hydraulic equations are very useful in the pump sets, water pumps, whatnot. See, we try to understand in the days to come. Now, see here, I would like to impress upon you. Here, okay, once again, hydraulic equation. Once again, one example I have written for your academic interest. Working pressure, okay, is transmitted by the fluid to every other part of the system. Working pressure moves to every part of the system. This is the fundamental principle that enables the fluid power to work. Okay, this is one thing. So I have written in several of my papers. That's why I am interested. Let us consider how a small, say for example, another thing I would like to share with you. Let us consider a small person can lift a heavy car. A heavy car is there. A small person, can he lift it? No. By using armed with a hydraulic jack, he can do it. Hydraulic jack, he goes on, it will lift. He cannot lift it. So these are all innumerable examples I used to take to my students. Okay, we'll share in the days to come as well. Now, what is the geostropic wind? Geostropic wind is very simple equation. Geostropic, simple. The wind moving parallel to the straight isobars. The wind moving parallel to the straight isobars. This is wonderful. These winds are characterized by a situation in which the Coriolis acceleration is exactly maintained by the horizontal pressure gradient force. So these winds exist approximately 500 to 600 meters, 500 to 600 meters, of course, above the surface of the earth, geostropic wind. So here in my book I have given very clearly basic terminology in agricultural meteorology I have given, terminology in environment, agricultural meteorology and agronomy also I have given. The last one is the cyclostropic wind. Cyclostropic wind. Here I would like to draw a small diagram for your academic interest before I explain to you. Of course, this is the one which most of my students usually enjoyed when I was drawing in explaining cyclostropic winds. That one also I would like to draw. Simple. This yellow, another one. We can say it there. This is the cyclostropic wind. What is it? Cyclostropic wind. Cyclostropic wind. This is what is this centrifugal force? Centrifugal force is it? This one pressure gradient force. Pressure gradient force. So this is the pressure gradient force. This is the source. Okay, centrifugal force. This is the cyclostropic wind. Why? Why I explain to you. Wind circulation. Okay, that results from a balance between the local atmospheric pressure gradient and centrifugal force. Centrifugal force, local, balance between the local atmospheric pressure gradient and centrifugal force. It can approximate the behavior of the wind in the atmosphere near the equator, where the influence of Coriolis force in the atmosphere is small. When Coriolis force is small near the equators, so there it works. So these are the usual factors. Once again, I would like to tell this is the cyclostropic wind. Cyclostropic wind. Okay, this is the centrifugal force. Okay, this is the pressure gradient force. Okay, this is what is the terminology for today's class. Again, may God bless you. I assure you that we learn more and more application in agronomy, agricultural meteorology.